All right, so in this video, we're going to be solving quadratics by factoring types 3 and 4. So type 3 would be when the b term is a 0, and type 4 would be when the c term is a 0. All right, so say we're given for when the b term is a 0, that solve 4x squared minus 16 is equivalent to 0. Okay, so what we mean by the b term is a 0, if you were to rewrite this in the standard form of a quadratic of ax squared plus bx plus c is equivalent to 0, then we can see that this would be 4x squared plus, there's no x's, so 0x, minus 16 is equivalent to 0. So the b term is a 0 for this because there's no occurrence of x. And we can think of it as this equation only has one occurrence of x. So x, the variable, occurs once. All right, so whenever that's the case, your equation is a quadratic because we have an x squared term, but x only occurs one time, then just solve it as a regular two-step equation, right? So to get the x by itself, you want to get rid of your 16. You want to first add 16 on both of your sides, and that gives you a 4x squared value of 16. And then divide by 4. That gives you an x squared value of 4. And then from there, the inverse of squaring to get the x by itself would be square rooting both of your sides. And that leaves you with the next value of the square root of 4, which in quadratics, every time you square root some number, it should be not just a positive 2, but a positive or a negative 2. All right, so why? Because think about it. If I were to ask you for 2 squared, that would be a 2 times 2, which gives you a 4. What if we were to expand negative 2 quantity squared? That would also give you a positive 4, because that would be a negative 2 times negative 2. And negative times negative would be an overall positive, and 2 times 2 would be a 4. So both a negative 2 and a positive 2 give you an answer of 4 upon squaring it. So both of them would be solutions for this quadratic. All right, so that's number 1. Let's move on to number 2 for type 3. Say we're given solve 5x squared minus 18 is equivalent to 4. All right, so again, there's no bx term for this, and there's only one occurrence of x. So just solve this as a regular equation. You want to first add 18 on both of your sides to isolate the variable of x, and that gives you a 5x squared value of 22. And then you want to divide by 5, and that leaves you with an x squared value of 22 over 5. And then from there, the inverse of squaring would be square rooting. And never forget that the square root of a number for quadratics would be positive or negative of whatever that square root is. And that right there would be the answer for this. All right, so positive or negative, the square root of 22 fifths would be that. All right, so just one more, number 3. Say we're given solve 6x squared minus 11 is equivalent to 3. All right, so same idea. You want to first add 11 on both of your sides. We only have one occurrence of x, so treat this as a regular equation. We have a 6x squared value of 3 and 11 gives you a 14. And then divide by 6, and that gives you an x squared value of 14 over 6, which simplifies on to a 7 thirds. Right, so again, 14 over 6 would be, if you divide the top and the bottom by 2, that would be a 7 thirds. And then from there, the inverse of squaring would be square rooting both of your sides. And that gives you next value of either positive or negative, the square root of 7 thirds. And that would be the two answers for this quadratic. Both the positive version of that radical and the negative version of that radical would be solutions for that for number 3. And for number 2 and for number 1. Okay, so now the other type would be when the c term is a 0. So we're given for number 1 for this case, solve 3x squared minus 4x is equivalent to negative 11x. All right, so in this case, there's no c term, as in if you were to rewrite this form of your equation, the c term, which is your constant, is not there, right? There's just a bunch of x's. So step 1 would be to bring all the x's over to one side. You want to add 11x and just combine these like terms, which we have a 0 on the right, and on the left we have a 3x squared, and then negative 4x plus 11x, that would be a 7x. All right, so once you have all the x's over to one side, all you would do is factor whatever you can from these two terms, right? So they both don't have a numerical GCF, but they both have a GCF of x. All right, so x times 3x gives you a 3x squared, and x times 7 gives you a 7x. And either the first factor of x should be a 0, or the second factor, which is 3x plus 7, would be a 0. And then the first one's already solved. That's your first solution. And the second one would be if you subtract away 7 on both of your sides, the next 3x should be a negative 7. And then divide by 3, and x would be a negative 7/3. All right, so in this step right here, everything is pretty much factored, right? So the first factor is x, and the second factor is a 3x plus 7. And once you have a factored quadratic, you just have to set both of your factors equal to 0 and solve both equations. All right, that's number 1. So number 2, solve 6x squared plus 8x is equivalent to 0. All right, so again, we don't have any constants for this, so you factor the GCF between these two terms. They both have a common factor numerically of 3, of 2, and algebraically of x. So 2x times 3x gives you a 6x squared, and 2x times 4 gives you an 8x. And then this is basically factored form, where the first factor is 2x and the second factor is 3x plus 4. And at this step, just set both of your factors equal to 0, and then solve both of your equations. In the first case, if you were to divide by 2, then x should be a 0. And in the other case, if you first subtract away 4, that gives you a 3x value of negative 4, and then divide by 3 to isolate the variable x, and that gives you an x value of negative 4/3. All right, so these are pretty easy. Let's move on to the last one, number 3. All right, so solve 8x squared minus 15x is equivalent to negative 8x. Okay, so again, we don't have any constants for this. We just have different occurrences of x. You want to first bring everything over to one side. You add 8x, and that gives you a 0 on the right. We have on the left-hand side an 8x squared. And then negative 15x's plus 8x's would be a negative 7x. And then they both have a common factor of x. And x times 8x gives you an 8x squared, and x times negative 7 gives you a negative 7x. And these are both of your factors, which if you set them both equal to 0, the first one's already done. X would be a 0. And the other one would be 8x minus 7 is also equivalent to 0. And if you add 7 first, 8x should be a 7. And then divide by 8, and that gives you an x value of 7 over 8, would be the second solution for your quadratic.